to work. Okay, there we go. All right, so I can't remember. I remember some of us are here. I have this handout. Who needs this one?
You need an extra one just in case.
Okay, we'll see if we have an extra one. Let's see. Oh, I also printed out the slide where it's the 7 powers. And that was from last time. So I can. The power didn't go out. But if I had put them off, I'm pretty sure that they would have gone out. Yeah, I think I have. Is that everyone? I think I have an extra set of slides and. Okay, so today we're going to talk about naming. Last time we talked about some basics that we need to understand in order to name, and today we're going to talk about how we actually name these organic molecules. So what we are going to use is this IUPAC naming system. So anywhere in the world that you go, chemists use this system to name compounds, so that when we are talking about a molecule, we can make sure that we're talking about exactly the same thing. So this IUPAC stands for International Union of Pure and Applied Chemistry. So that's where our naming rules are coming from. So yes, somebody did just make this up, but it is systematic and the whole world follows this. Okay, so everyone is, this is unique. Every molecule has a unique name. This is kind of like, I was reviewing the slides today, and this is kind of like a game. So have you ever gotten a new game, and you pull out the instructions, and it's like, if this happens, draw 2 cards. And if this person does this, then this happens. And there's all these different criteria for like when different cards come up or different situations. So this is just like, we're getting the rule book for the game that is naming organic molecules. So if you think about it like a game, a rule book to the game, that's a little bit better than what we're actually doing. Okay, so this is just kind of interesting. Most drugs have 3 different types of names. They have a systematic name. So this would be the IUPAC name that we're going to talk about how to name. This is way more complicated than what we're going to name, but this would be like 2,4,2-methylpropyl-phenyl propionic acid. And generically, this would be ibuprofen. So this drug, ibuprofen, has an IUPAC name based on all the branches and the chains in the organic molecule. And then we also have a trade name. So this is like, I made it, I have a special process to make it, so I'm going to call it something special. And then I'm going to sell it. So Motrin and Advil have the same ingredient, they have ibuprofen, or this other name for it, but they have patented a way to make it. So that's kind of interesting. So we're talking about the IUPAC name today. So when we're naming based on the IUPAC system, there's basically 3 parts that we need to look for. So we have a prefix. That's telling us what substituents we have, that's the branches, and where they are. The parent, and this is what we talked about last time, identifying the parent chain. The parent chain is the longest continuous carbon chain in the molecule. And then we're going to talk about this a little bit later, I think in chapter 13.
I have to go through the check.
Oh, okay. See ya.
See ya.
Good luck.
Thanks.
And then the suffix is like if there's anything special. So do you remember we talked about OH groups or hydroxyl groups or amino groups? We can look at the suffix to see if it has any special functional groups. So this is a basic form for naming. And then we have all these little rules, just like in a new board game that we have to follow. And then we are going to start going through the rule book for naming. And I have the rules written on this sheet. So as we go through the rules, you won't have to write down all of the rules. And as you get more and more complicated molecules, you can add to the rule book. But these are the rules we're working with now. This is kind of tedious, but if you think about it as a game, I think maybe that will be more exciting. Questions or comments so far? Oh, also, you are lucky. Yesterday, it was 86 in here.
Oh.
And during second period today, they were able to fix the air conditioner. So now it is not 86 in fourth period. All right, so again, these are on your reference sheet, your note sheet. And we're just going to go through our board game rules for the game of naming alkanes. So the first thing that we're going to do is we're going to find the longest continuous carbon chain. So that's what we talked about last time. And we're going to name it with an ane ending, because if we don't have any other functional groups, then ane is the ending. So we talked about last time. We have this list here of our parent chain. So if the longest one is 7, the longest carbon chain is 7, then we're going to name it heptane. That's the parent. And then we're going to number the atoms in the carbon chain to give the first substituent the lower number. And we also talked about that last time. So we want to lower the first substituent number. And we talked about if there's a tie, then we're going to look at the second substituent and try to reduce the second substituent. Okay, and then we're going to name the substituents. So the substituents, when I'm talking about substituents, I mean the branches. So not part of the main chain. So we're going to name those using the alkyl groups. And we have 2 different tables. This gray one is from Alex, so I will use this one. So if there's 1 carbon substituent, that would be a methyl group. And we also talked about propyl has 3, but propyl can be attached by just the end of the 3 or in the middle of the 3 carbons. So we can have propyl or isopropyl. And then we're going to designate the branches with the numbers that we numbered the carbons. Okay, so the carbon has to, if there's a carbon in the molecule the carbon has to be identified either in the carbon chain, so it has to be part of the, if it's heptane, it has to be in the heptane, or it has to be the branch. It can't be both. Okay, we'll practice. I think it'll make more sense when we do a few examples. Each substituent needs its own number. So even if there's 2 on one spot and it's the same thing, we have to say, oh, there's 2 things at the 2 positions. So 2,2-methyl, something like that. If we have 2 or more substituents, and they're identical, then we're going to use prefixes to tell us how many are on the main carbon chain. So we know these prefixes. We might have like hex. We might have 6 different methyl groups. So if we had 6, then we would use hexamethyl, something like that. Okay, and again, I think if we look at some examples, it'll make more sense. So we're going to look at our molecule, figure out where the substituents are located, what number, what position they are. We're also going to name them using our substituent boxes. And then we're going to name it using we're alphabetizing the substituent group. So we have methyl groups, we have ethyl groups, we have propyl groups, we have isopropyl groups. So ethyl is going to come first. If we have an ethyl and a methyl, ethyl is going to come first because it starts with E. So we alphabetize the substituent groups. And then the name of the substituent gets the number. So it's like the methyl group is out of 2 position, we have a 2-methyl. And we talked about, I think that was already, there must be one number for each substituent. And then we're going to separate numbers by commas, separate numbers from letters by dashes. No spaces. Okay. Let's go ahead and look at an example. Do you want to try this one, or should we go through it? Should we go through it together? Okay. I think this should work. Okay, so the first thing that we do is we have to find the longest carbon chain, and we practiced that last time. So the longest carbon chain is not necessarily the one through the middle. So if we're looking at this, to me it looks like this is the longest carbon chain. And I can always count and recount. So I'm going to say 1, 2, 3, 4, 5, 6. So that to me looks like the longest. I can always check, maybe I want to try like 1, 2, 3, 4, 5. Oh, that's not longer. What if I go this way? 1, 2, 3, 4, 5, 6. So that would be the same pathway. So I need to find the longest pathway. The second thing I'm going to do is I'm going to try to number it so that the first carbon substituent, the first branch, is at a lower number. So we could number it in 2 ways. We could go 1, 2, 3, 4, 5, 6. Or we could start at this end. 1, 2, 3, 4, 5, 6. So which direction, from the left to the right or the right to the left? We want to minimize the first carbon group. Yes, right to the left, because this will put the carbon at the 2 position. So 1, 2, and then our substituents, our branches are at the 2 position. Instead of, if we go this way, 1, 2, 3, our 2 carbon groups are at the 3 position. So we want to minimize the first branch. Okay. Oh, we also need to name the parent molecule. So this is 6. What should we call the parent chain? Hexane. Good. Because it has 6, so we can use this table. So 6 is hexane. Okay, then we need to figure out what groups we have. So this was our parent chain. So if it's part of the parent chain, it can't be a side chain. So those are spoken for. So what groups do we have left? CH3. And we have one here, one here, one here, one here. Okay, what do we call CH3? And we're gonna look in either of these boxes. Yeah, good. This is a methyl group. And we talked about that in the last chapter too, methyl. Okay, and this would be, we are going this way, so this would be 2-methyl. 2-methyl. Put a dash between letters and numbers. So we have 2-methyl. What's this one? Also 2-methyl. Okay, and then we have these two. What would these be? This would be 4-methyl. And this is also 4-methyl. Oops, 4-methyl. Okay, so we have 4 methyl groups. So we're going to use a prefix. Instead of saying 2-methyl, 2-methyl, 4-methyl, 4-methyl, we're going to say tetramethyl. And we're going to say where they are. So we're going to say there's one at the 2, there's one at the 2, there's one at the 4, there's one at the 4, tetra, methyl, hexane. Oh, I better fix this. No space. There's no space. So those words are right up next to each other. So let me write it again. So this would be 2, 2, 4, 4, tetra, methyl, hexane. Okay. We're doing okay so far? Okay, questions where anything came from? Okay. And I put it here just in case I forgot how to do it. So we are going to order numbers. We're going to go lowest to highest on the numbers if there's a group of all the same group. Okay, do you want to try one? Okay, here's another one. Try this one. And we will go over it, but try to see if you can figure out where you're, if you have any questions before we get too far.
So I'm just confused. It says to add a row, so there's 2 different ones.
So this one, so what's the longest carbon chain so far? That's the longest. Okay. So then off that main chain, what groups do you have? Yeah, that one. Do you know what that's called? So that one is like this. So you're going to be identified based on this. So you have, how many carbons are there? 3. End, middle, end. So that's 3. Do you see that? Okay. So 3. So it's either 1, 2, 3, 1, 2, 3. It's either propyl or isopropyl. So which one do you think it is? Is it isopropyl like branch in the middle or propyl? Yes. So, and then what position would you put it at? Yeah. And then Oh, and then you add a row because you have, so there's a substituent here, there's a substituent there, and one down there. Oh, and so it would be at the location. So you said this is 4, 1, 2.
Still confused, I just wrote down the numbers and so on.
I'm about 4, 4,
Propyl.
Okay, good. Okay, let's write down some names that we came up with. What did you, or tell me some names. What do you decide?
I know 4,4-ethyl propylhexane. That's probably wrong.
Okay, and so we want to put commas between the numbers, I think. I get that confused, and Alex will mark it wrong, so it's numbers by commas. 4, 4. So, okay, what's next?
Dash ethyl Purple heptane.
I don't know.
Okay, I think that's a great start. Does anyone have anything different?
I just got to the numbers on that.
You just got to the numbers. Okay. So this is really close. So the only thing that I would change is you need to put the number in front of because they're different.
Okay.
So this would be for ethyl, for propyl.
Okay.
Yeah, but very good. Okay, and we put the numbers all together because all the methyls, they were all just methyls.
Okay.
So this is just like a different example.
Okay.
So yeah, very good. So did you start numbering from this side or that side?
I think from the bottom.
From the bottom. Okay, and this one actually doesn't matter. 1, 2, 3, 4. 1, 2, 3, 4.
Just so
Yeah, good. So let's do that. 1.
How do you know
Two.
where to number?
You gotta try it. You number it and
I-
see.
I went from the right.
Okay. This one?
Yeah,
Okay.
that way. That's where I went from.
2, 3, 4, and then where? 5.
And then up or down, really.
Okay, yeah, right. 5, 6. This is a kind of funny molecule. This one's really symmetrical.
Yeah.
So it's all about the 4 here. So no matter which direction, you'll get a propyl. So this is our propyl group. We'll go with this way. We have our propyl side chain, and we have our ethyl side chain. And any way that you flip it, you're going to have an ethyl and a propyl. Okay, so sometimes it works out.
Okay,
That
that
way.
makes more sense. Now I know.
Okay. All right, so remember, so this is our carbon chain. They can't be part of the side chain. They can't be a side chain if they're a main chain. So then we have 3, which is our propyl, and that's at the 4 position. And we have 2 carbons, that's an ethyl group, also at the 4 position. Okay, how did that go? Did it go okay? Okay, so you kind of have to watch for 2 things. You have to watch for the naming rules, but then you also have to type it in correctly. Alex doesn't want dashes where there should be a comma, it doesn't want commas where there should be a dash, and it also gets mad if you put a space. So there's all these like little kind of spelling rules that you have to watch out for too.
On
Okay.
the test,
Yes.
if we like write it down on paper, but we type it in and Alex wrong, could be something like
Yes.
partial.
Yes, yeah. And that's, true. Okay. All right, very good. And we forgot to talk about this. The ethyl comes before propyl, why?
Alphabet.
Alphabet, good. E comes before P, good. That's lots of little rules that we have to keep track of. Okay, I think this is the last one. Oh, yeah. Try this one. This is drawn weird because I used a different software, so it looks slightly different than what you might see. Yes.
Would there be 8 carbons in it, or is it only 6? Like, does this?
Yeah, this one looks like it has 8.
Okay,
The
so
longest chain would have 8 there.
okay,
Or is that your question?
yeah, that's what I was saying.
So Sebastian, did you figure out the parent chain?
No, I don't think so.
So what's the longest chain? How many carbons does the longest chain have? That's a good place to start.
So it'd be one on the right. The CH2 and CH3, right?
So, and then that's connected to another carbon, connected to another carbon, connected to another carbon. And so keep counting until you get to the end of the carbon. How many?
Six. Or no. Because I'm just confused. It doesn't make sense to me.
So some of this is condensed and some of it is not condensed. So it's a little bit tricky.
That makes more sense.
So hydrogens are just to fill in. They're just there. Yeah, we don't care about naming them. Like in the skeletal structure, they will show up. Good question. This is just drawn kind of funny. So they kind of look like side chains, but they're not. They're just hydrogen hanging out there. Yes. Oh, so that's what we're doing here. So you'll count this way, 1, 2, 3, 4, 5, 6. So hexane will be the parent. And then this is a methyl group. It's at the 2 position, so it'd be 2 methyl, 3 chloro. Chloro will go first because C comes before N. So it'd be 3 chloro, 2 methyl. And then you have to put those go before it. And 3 dash. Yep. And then dash. 2 dash. And then yep, no space. Yeah, it's kind of weird. Yeah, good. Okay, what did you get for this one? What do you want to call this one? Oh, you're almost there. Or Cameron, you're thinking? Okay, share with us, Cameron.
Do you want me to say like dashes?
Sure, yeah.
5 dash ethyl.
5 dash ethyl?
Uh-huh.
Okay, they just sound similar, so I'm just making sure I got it right. Ethyl?
2,6 dash dimethyl octane.
Okay. Okay, do you agree with that? Okay. Okay, let's see. So you decided which direction did you decide to count from? This side or that side?
Left side.
Left side. Okay. So you said 1, 2, 3, 4, 5, 6, 7, 8. So those are all part of the parent chain. They can't be a side chain anymore. So then we can look at the side chains. So then you have this 2 at the methyl. And good, you have this 5 ethyl. And another methyl, 6 methyl. Okay, very good. And then how did you decide that ethyl should go before dimethyl?
I just hope.
You just hope, okay.
Said to ignore the previous.
True, good, yes. So and, oh, I don't know how to fix that now. That's never happened before. Maybe escape. Oops. We'll keep that.
Oh,
Okay. Oh, that's because it's on both screens. That's what. Oh, very good. Here we go. Okay. Yeah, so the N, we always look at the N. Oh, now it's not gonna do the pen tool. We'll use our pen. There we go. Okay, so good. M comes before, oh, that's kind of weird. Okay, we'll just point. M comes before E, so good. And the prefix, we ignore that. Good. Okay, questions on that? Do you think you can do that on the Alex homework and on the test? If you practice a little bit? If you have any questions, you're squinting.
Just practice.
Okay, yeah, I think that the more practice you can get with this, the more examples you can see, the better you'll get at this. Like a game, right? So, okay, the rest of the time, good. The rest of the time, we have 25 minutes. The rest of the time, I would either work on lab 5. You can do the pre-lab for lab 34, or work on the chapter 12 Alex homework. You could also work on we have the signature assignment, don't forget that. Or you can also review for the final. Yes, let me turn this off.